Hello. Now here is another problem from chapter variable mass. Let's read the question. A particle of mass m, capital M, is initially at rest, starts moving under the action of a constant force Fi, F into I cap direction. It's encountered the resistance of a stream of fine dust moving with a velocity minus v naught I cap, which deposits matter on it at a constant rate rho, so that its mass will be small m when it has traveled a distance of this much. So we'll see what are the keywords are there. Particle of mass m. Initial mass the particle was m. Next keyword comes the initially at rest, starts moving under the action of a constant force. Another thing that it encounter resistance of a stream of fine dust, resistance of a fine dust, which is moving with a velocity of minus v naught I cap. It deposits matter on it at a constant rate rho. What is given? dm by dt is equal to rho. Then its mass will be small m. At what time mass will be small m? When it has traveled a distance of this much. So its mass. So basically we have to find out mass as a function of s. So after traveling this much distance, its mass becomes small m. Changes from capital M to it has changed to small m mass. That we'll see. Let's solve it. Let's see. This is the particle of mass m that we have seen, and this particle is mass m, and it is moving with a velocity v at any instant of time. And these are the dust particles are there, and dust particles are moving with some velocity v naught towards the left. So as the particle is moving, it is encountering the dust. Dust is getting deposited on the particles, and because of that, the mass is keep on increasing. So as the mass is keep on increasing, what will happen? Its speed will change. It will have some acceleration. So we'll be calculating the thrust. The dust particle will be applying the thrust on it. So what are things given to us? Let's check. One thing is given that it is given that this dm by dt is given as rho, constant rate value, rho value it is given. It is given at the rho rate mein it is getting deposited. Okay. And on this particular another force F is acting. Somebody is applying one force here. Okay. F I cap is added. That is also constant force is there. So what will happen on this initial mass of the particle is capital M. It is given the question, and what time it will be equal to m, that we have to find out. So anytime you take the m you have taken. So on this, if you draw the free body diagram of the particle, on the free body diagram of the particle, if I draw this one force F will be there. Another force thrust will be acting on this. The thrust. So what is the thrust there? We know the thrust is equal to dm by dt into v relative. So the thrust magnitude we are calculating, dm by dt is equal to rho given here, and the relative velocity of the dust particle with respect to system is equal to v plus v naught, or v naught plus v. Okay, so this value has to be substituted. So this is equal to thrust is equal to rho times v plus v naught. Once you've got done this one, everything is over. The bending problem is very, very simple. So if I write the equation of motion, then equation of motion will say that, so from the free body diagram we can write the equation of motion like this. Equation of motion will be F minus rho times v plus v naught thrust is equal to mass time acceleration. But in this, mass is not constant. This m is equal to initial mass plus rho t. There the mass is there. We need to substitute these values and we'll to set up the differential equations. This I can write the equations like this, and I can write here m naught plus rho t, and in place of a I can write dv by dt, rate of change of velocity, is equal to f minus rho v plus v naught. From this we need to set up the differential equation, and let that look. So taking this to, we got this. After that we need to integrate, and before integrating we have to substitute the limit. Here f is constant, rho is constant, v naught is constant. only v and time as variable. At t is equal to 0, the particle was with the velocity v naught, this is equal to 0, 0 velocity moving. At any time t, what will be the velocity that we need to substitute? So we'll go to and we'll write the next set of the solve the differential equations. This left hand side differential will be 1 by minus rho and ln of f minus rho times v plus v naught, and we have to substitute the limit from 0 to v, and this is equal to 1 by rho and ln of m plus rho t, and we have to substitute the limit from 0 to 2. See this row and this row, they get cancelled out, and after substituting limit I can take the ln on both the sides, can be exponential on both the sides, so ln will be over and I'll obtain f minus rho v plus v naught by f minus rho v naught will be equal to m by m plus rho t. And if I take in substitute and simplify, I can get the value as the v as a function of v as a function of t can be obtained, and I'll write the equation. It will be equal to v is equal to minus v naught plus f by rho plus f minus rho v naught by rho into m by m plus rho t. These are the equations will be there. We'll go to next page and check. So velocity, we get this relation, and I can put it here in box. So if you see this, we got the velocity as a function of time as we discussed. So but we don't record velocity as a function of time as I told you. So in place of v, what I'll write is a ds by dt to obtain is equal to this. I'll take this dt to this side, this will be dt to this side, and this whole quantity I'll be taking dt to this side. Then I'll get s, and after integrate with the suitable limit, I can get the value of s after integrating dt to this side, and s will be equal to ds integration will be equal to this quantity into dt. I have to integrate, and after integrating I'll get the value. Get the values s equal to minus v naught t plus f by rho t minus f minus rho v naught by rho into m into 1 by rho ln of m plus rho t by m after substituting the limit. So this can be simplified, and once I simplify this one, I'll get the final value as this as a function of time. I can simplify, and I'll write s is equal to f minus rho v naught by rho into, inside the bracket it will be equal to t minus m by rho ln of m plus rho t by m. Now we want a particular time. What is the time is saying? The time is saying that at what time does mass m get converted from capital M to small m. So that we calculated that m plus rho t should be equal to m. M plus rho t should be equal to m, or t should be equal to m minus m by rho. This value, this t value, I will substitute here and here, or directly I can substitute also in place of m plus rho t. Directly I can substitute the value of m. So t value I will take here and substitute. I'll get the equation as s is equal to f minus rho v naught by rho square, and in place of this will be coming out to be equal to m minus m by rho I have taken outside, and plus m, as you can, one row I have taken outside, this will be equal to m into ln of m by m. Further, from these two terms, again I can take m common, so this will be equal to this quantity can be written as f minus rho b naught by rho square. M is outside, minus I take m common, so 1 minus ln of m by m. So this is my equation got S. So after this much displacement, the body's mass will be converted from capital M to small m. The particle is going, dust particle accumulated. So this mass was capital N, it get converted into small n after a displacement of S. Now let's check what the question was there, what the question asking. Let's refer the questions once. So question was telling that at a time of after a displacement so that its mass will be small m when it travel a distance of this much. This is the travel distance. This is a unitary axial motion. So displacement magnitude will be distance f minus rho b naught by rho square small m minus capital N 1 plus ln m by m. Let's check the answer. We have also obtained S is equal to rho minus f minus rho b naught by rho square m minus m capital M small m minus capital M into 1 minus ln m minus m. So our answer is correct. If you like the solution, press the like button. And you have any further doubt, any other questions to be discussed you want, then please mail me to writefunda@gmail.com. We'll be taking in the doubt discussion session.